Hello students, today we are going to discuss cauchys intro test. Okay, I got a demand from the student regarding this cauchys intro test, so I thought we can discuss the cauchys intro test. So now you can see what is cauchys intro test and how to do it, how the questions will come in exam. Okay, so we start. Cauchys nth root test, or simply we can say that it is a root test also. There are two names here. Cauchys intro test or simply root test. Now see what is the statement. If summation un is a series of a series of positive terms, series of positive terms, such that such that limit n tends to infinity, limit n tends to infinity, nth root of un means un to the power of 1 by n is equal to L. Then case number 1, first case, if this value of L, whatever we obtained here, that is, if it is less than 1, then we say that the above series is convergent. Till now, whatever the problems we have done already, in those problems, we are going to say the series will be convergent if L value is greater than 1. But here, for this Cauchy root test, the process will be reversed. Okay, in exam, they may ask you the only statement of this Cauchy root test. Now, second possibility, if L is greater than 1, then we say that it is divergent. Reverse process, remember, okay? Then it is divergent. And similarly, as you know, we have a third case also arises here. That is, if this value of L is equal to 1, then we say that test fails. Then test fails. So once test fails, we have to see at for what value the test fails, and then we have to substitute that value and we continue. Okay, and here some of the formulas are also required, so let me write those basic formulas which we are using here in our Cauchy's intro test. Those formulas here you can see is formulas. Some formulas are needed here. Formulas. Number 1, as you know, we have already used these formulas in the previous test, but still I want to write limit n tends to infinity 1 plus 1 by n whole to the power of n. This value is equal to E. Second formula. These formulas are not new. Already we have discussed before. Still I want to write limit n tends to infinity 1 plus 1 by, instead of n, suppose if you have root n, this is root n, and to the power is also root n. In that case also this value becomes E only. Okay, so root n may be possible sometimes, n plus 1 is also there. Then in that case also that value will become e only. Another formula, that is limit n tends to infinity 1 plus x by n, x by n whole to the power of n, that is equal to e to the power of whatever may be the value here, that will come here. It means it is e to the power of x only. Here also, if you consider that value is 1, so e to the power of 1 will be there actually. So it is also e to the power of 1 only. But here in place of 1 we have x, so answer is e power x. So I repeat once again, this is cauchys n through test will come in exam for 2 marks only. But unfortunately last in 2023 question paper, he is given 2 questions, the 2 as a long answer. So this is depends upon the examiner. He may give any question for as SAQ, any question for as LAQ. So we have to go for that one by one. We can see some of the questions as an examples, how to implement this one. So as an example, let me do it one question. And now one question will start. Number one, question number one. The question will be coming in this way. As I said, everywhere it is going to mention test the convergence. You have to identify that which test you have to apply. Test the convergence. Test the convergence of. Here the question is summation n upon n plus 1, n upon n plus 1 whole to the power of n square. So first of all, I want to give you the answer of your basic question, that is how to identify that it is this one. We have to use for this problem, we have to use nth root test only to solve. So first identification is, if the power is in terms of n, then it is sure that we have to apply nth root test only. You can see the power is n here. So we'll write the solution here. Here, as I said, summation value itself is a un value. It is equal to, our question is n upon n plus 1 to the power of n square. So if the power is in terms of n, it means that we have to apply root test only, cauchy root test only. Now if you see, we have only 3 steps. Step number 1, un value will be there. The step number 2, you have to take the nth root. Nth root means we have to apply whole to the power of 1 by n on both sides. So first step is there clearly. I want to move to the second step. I am going to raise the power as 1 by n on both sides. So n upon n plus 1 to the power of, we have already n square, and its power we are going to be take as 1 by n, means we are going to take the nth root. The square root means power 1 by 2, cube root means power 1 by 3. Similarly, nth root means we have to take the power 1 by n on both sides. Now if you continue this problem, as we know, this power whole power means we can multiply these two powers. We have a basic formula in elementary classes. You know this formula, this one, a to the power of m. And if you have a power whole power n, means we can multiply these two powers. It means we can also write it as m into n. Similarly, the same story will be continuing here for this problem. Un upon un whole to the power of 1 by n is equal to, once if you multiply these two powers, it means n upon n plus 1. Okay, now multiplying this n square into 1 by n. n square into 1 by n. And if you simplify, we know that this term with this cancel it. Okay. So then un whole to the power of 1 by n is equal to what's left of n upon n plus 1 whole to the power of n only left here. Okay. Whole to the power of n only left here. Right? Any doubt in this? Now what actually I want to do it here is un is equals to un whole to the power of 1 by n is equal to this one. I want to write in a different way. It means if you take the reciprocal of this, it means like that n plus 1 whole to the power of n. If you take the reverse of this power will become negative. I will give you one example to understand this basic. Like if you have 4 by 5, for example, 4 by 5 whole to the power of 2 is there. If you take the reverse means it is like that 4 by 5, and this will becomes power minus 1 and then whole square. Then this minus will be multiplying. This is becomes 4 by 5 whole to the power of minus 2. It means that if you take the reciprocal for any fraction, the power will become negative. So that example we have to use it here. Un whole to the power of 1 by n is equal to, now what I am doing, I am simplifying like that. N upon n becomes 1 plus 1 by n whole to the power of minus n. Also I want to write in a different style. The way of writing is just okay, let us write this step as it is. Next step we can do it. What we can do it, minus n to thoda sa we'll write in a different way. What is the way? You can see different way will be yes, un whole to the power of 1 by n is equal to, in this way I want to write 1 plus 1 by n whole to the power of n and whole to the power of minus 1. Right now, if you multiply with minus 1, you will get minus n only. Okay. Why we are going to do like this way? Because we have 3 steps only. Un value is there. We have to take the nth root we have taken. Now the final step is we have to take the limit n tends to infinity on both sides. Limit n tends to infinity un whole to the power of 1 by n is equal to, what happened here is limit n tends to infinity, 1 plus 1 by n whole to the power of n and whole to the power of minus 1. Why I am doing, यहाँ पे भी अपन क्यों करें, why we are doing all this reciprocal and power, why we are going to make it negative? Actually I want to get this format because we know the formula of this. What is the formula? We know already. This one यहाँ पे लिख रहा हूँ. Here I am writing limit n tends to infinity 1 plus 1 by n whole to the power of n. That value is equal to e. Already we know this value is e. So then our answer is what? If you want to replace with the e, then it becomes what you will get here, e power minus 1, which can be written as 1 by e, which is nothing but 1 by e value. If you see in your calculator, it is 2.71 something. That is definitely less than 1. Means which value is less than 1? Un upon un to the power of 1 by n value is less than 1. So by cauchys nth root test, by cauchys nth root test, or simply you can say that root test series. You know, for less than 1 what we have? For less than 1 we have, it is by cauchys root test given series, matlab un value is 10. This is the end of this problem. Our intention is to check whether it is convergent or divergent. Only two possibilities are there. Okay, this is the problem which we have completed. Okay, if you understand, now we can move on to the next question. Moving to the next question. Let us see. The next question is number 2. Question number: examine the convergence of the series. Examine the conver convergence of the series of the series. Examine the convergence of the series. Abdul Bari, your sound is coming here. The question is 2 to the power of 2 by 1 to the power of 2 minus 2 by 1 whole to the power of minus 1 plus 3 to the power of 3 upon 2 to the power of 3 minus 3 by 2 whole to the power of minus 2 plus 4 to the power of 4 divided by 3 to the power of 4 minus 4 by 3 whole to the power of minus 3 plus and so on. We are going to check whether it is convergent or divergent. So now you can see the solution. Now, first of all, what we have to do, we have to get the value of un. As I said, we can easily frame the value of un. If it is starting with 2, as I said, starting with 2 means n plus 1 is the nth term. N plus 1 for power 2. 2 means again n plus 1. Denominator is again 1 means n. 2. 2 means 2 means n plus 1 minus 2 means n plus 1 upon 1 means n whole to the power of minus of 1 minus 1 minus 2 minus 3 means minus n. This is the value of. Okay. Now for your convenience purpose, what I want to do it, I want to solve some steps. Un is equal to, you can see, notice here, numerator and denominator will have the same power. Numerator, denominator will have the same power. So we'll write together. Together means what? N plus 1 upon n whole to the power of n plus 1. आप ले लो n plus 1 whole to the divided by n whole to the power of n plus 1 minus n plus 1 divided by n whole to the power of minus n. Okay, then we have to simplify some more steps, and then we have to take the nth root. So the steps which we are going to be simplified, you can see very carefully. Okay, now see here. un is equals to n plus 1 upon n to the power of n plus 1. Now I want to split it to the power of n here and n plus 1 upon n whole to the power of 1 here minus n plus 1 upon n and whole to the power of what we have here minus n. Now taking nth root, this is un to the power of 1 by n. It is equal to, आप ये चाहे तो पहले स्टेप में भी कर सकते थे, it is up to you, n plus 1 upon n whole to the power of n into n plus 1 upon n minus n plus 1 upon n whole to the power of minus n, and we are going to raise the power, that is whole to the power of once again whole to the power of 1 by n here, right? So this n with this n cancel, so this power will become negative. Un to the power of 1 by n is equal to n plus 1 upon n whole to the power of n into n plus 1 upon n minus n plus 1 upon n, and this power will be minus 1. Now if you notice, here we have something is there to take common. This is the something. Means n plus 1 upon n we can take common. So let us take it out. Un to the power of 1 by n is equal to, you have to take n plus 1 upon n will be outside. To take common, it is becomes, here left off is n plus 1 upon n whole to the power of n. This term is already outside and this term is also outside this. And you see, this will come outside along with the power minus 1. It will also will have the power along with the power minus 1. So now if we simplify further, see here, un is equals to what we have done it in the previous problem. I want to take the order, change of order, n upon n plus 1. So this power minus will become plus here into, okay, what I am doing here is same thing, what, changing the order, n upon n plus 1 whole to the power of, it is becomes negative n minus 1 and whole to the power of minus 1, right? This is un is equals to un to the power of 1 by n is equals to, if you cancel the terms, but here only we can take power negative only. We'll do one thing. Instead of doing this step, we'll do one thing. Because if we cancel it, okay, we'll do one thing. We don't want to take the reciprocal. I don't want to take the reciprocal here. Here only we'll do some corrections. Right. What actually I want to do it here is, here only we take n common. N common means n common. 1 plus 1 by n whole to the power of minus 1. Here also whole to the power of minus 1. Similarly, same story here also. It means n power n common from the numerator. So there it is becomes 1 plus 1 by n. From the numerator we have taken n power n common divided by this power we apply for numerator and denominator also we apply. It is like that. Minus 1 and whole to the power of minus 1 also as it is. So now n power minus 1 can be written as 1 by n. This and this will be cancelling here. It's n power minus 1. And denominator also we have here n power minus 1. Even though this and this also cancel. Now taking limit n tends to infinity on both sides. Limit n tends to infinity un up whole to the power of 1 by n. Now we'll take the limit here. Limit n tends to infinity 1 plus 1 by n whole to the power of minus 1 into this limit will go inside also. Limit n tends to infinity 1 plus 1 by n whole to the power of n minus limit of the constant is constant itself whole to the power of minus 1 itself. Now as n tends to infinity 1 by n tends to 0. So 1 to the power of minus 1 is equal to 1 to the power of minus 1 means 1 by 1, that is equal to 1 only. So nothing will happen here this side, but here this is equal to this is anyhow it is 1 only, and we know that this value is this is 1 multiplied by this value is e minus 1 whole to the power of minus 1. So if you simplify, we are getting e minus 1 whole to the power of minus 1, which is equal to 1 by e minus 1. And already we know that if e value is 2.71, if we want to simplify it is 2.71 minus 1. Whatever the answer, but definitely less than. So by root test, by root test, summation un. This is the way we have to solve the problems. So this is the end of the class and end of the lecture also.